Welcome back. This is it, the final chapter of our IRL Keywords series. We've built the foundation, and today we're adding the most advanced tools to your toolkit. Let's finish this journey. By the time we're done here, you're going to have the complete vocabulary to tackle just about any business rule you can think of. We're covering everything from basic structure and how rules execute, all the way to memory management and some really cool event processing. So first up, let's talk fundamentals. All right, let's start with the architecture, the keywords that really define the shape of our rules. You can think of these as the blueprints you need to keep your logic clean, organized, and ready to scale. So these keywords are all about creating a nice, tidy container for your logic. A rule set, that's like your main package. Property definition is super useful. It lets you attach metadata, like who owns a rule. Use is your standard import for pulling in external functions, and variables is for declaring local variables right up front. It's all about building on a solid, organized foundation. This right here, this is the core DNA of every single rule. It's a really simple but powerful flow. You start by defining the rule. Then the when part sets up the main condition. What are we actually looking for? The where clause can then jump in to add even more specific constraints. And finally, you have then, which defines the action. What happens when all those conditions are met? And here's what that looks like in actual code. See? We define the rule as check age. The when block is looking for a person object whose age is less than 18. If it finds a match, boom, the then block kicks in and calls the setMinor method. It's simple, it's clean, and it's just plain logical. Okay, so we've structured a single rule, but what happens when you have a whole bunch of rules? How do you control how they all run together? That's what we're going to tackle next. Managing the flow. In a rule flow, you don't just unleash all your rules at once. That would be chaos. You organize them into logical steps. A rule task is basically a block that holds a specific set of rules you want to execute together. Then, the rule keyword, when you use it inside that block, tells the engine exactly which rules are part of that specific task. And here's what that looks like. We've got a rule task called eligibility rules, and inside those curly braces, we just list out the rules we want to run for this task. Check credit and check income. This gives you really precise control over the entire flow of your logic. Now, this is a big one for performance and predictability. Usually, the engine uses a super sophisticated algorithm called RAIADE for pattern matching. But what if you just need your rules to run in a simple, predictable order? Well, that's exactly what sequential is for. It tells the engine, hey, skip all that complex matching and just run these one by one, top to bottom. But what if the order of your data is what matters? The sorted keyword gives you total control over that. Before the engine even starts looking at conditions, you can tell it to sort all the incoming facts, say a list of customers, based on whatever attribute you want. And check out the syntax here. Inside the when clause, we're not just grabbing any person object. We're specifically pulling from a collection that has been sorted by age, in descending order. This guarantees we process the oldest person first, which is absolutely critical for things like seniors first discounts or priority handling. Awesome. So we can structure our rules and control their flow. Now, let's zoom in on the data itself. This next set of keywords is all about managing the facts, the live objects that are floating around in the engine's working memory. You've got three main tools for this. Retract is super straightforward. It just removes a fact from memory, completely gone. Refresh is what you use when an object's data was changed by something outside the rules. It tells the engine to take another look at it. And then there's update, which signals that an object is changed inside the rule, telling the engine to reevaluate everything that depends on it. Now, it's really important to get the subtle difference between update and modify. Remember, modify needs a whole block where you actively make the changes. Update is more like a quick shorthand you use after the changes are already done. It's just a simple signal to the engine like, hey, this object is different now, you might want to recheck your work. This slide shows them in action right inside a then block. So we might change a property on an order object, and then we'd call update order to let the engine know. Or maybe after we're done with a temporary calculation object, we can call retract temp calculation to clean it up and free up memory. All right, let's move on to some keywords that should look really familiar to anyone with a programming background. IRL actually borrows a lot of standard control flow ideas to make writing complex logic way easier. And here they are. You've got return to exit a code block early,
Switch gives you a much cleaner way to handle things than a huge, messy chain of if-else statements. And for loops, you have while, which keeps going as long as a condition is true, and its opposite, until, which loops right up until a condition becomes true.
The switch statement is a perfect example of this. Instead of a crazy nested if-else mess, you can just neatly check the order.status and have a specific case for new, closed, and a default for everything else. It's so much cleaner and easier to read. And for building really robust applications, you also get full-on exception handling. You can throw an exception if something goes wrong, and you can wrap your risky code in a try-catch block. Plus, inside your rule flow loops, you have break and continue to give you that fine-grained control over how they execute.
This shows that classic try-catch-finally structure. You try the piece of code that might fail, you catch a specific exception to handle the error gracefully, and the finally block, that contains cleanup code that is guaranteed to run no matter what happens. This is absolutely essential for building resilient, production-ready rule applications.
And now for our final section. We're about to get into one of the most powerful things a modern rule engine can do: complex event processing, or CEP. This is where things get really, really interesting. This is where rules stop looking at a static snapshot of data and start analyzing a constant stream of events as they happen over time. We're talking about real-time fraud detection, system monitoring, complex logistics, you name it. These next few keywords are your ticket into that world.
These three keywords are basically designed to work together as a team to manage time-based logic. Time_of lets you grab an event's exact timestamp. Wait can actually pause a rule, listening for another event to happen within a specific time window. And timeout is your fallback plan, what to do if that event never shows up. It's this combo that lets you build rules that are truly aware of time.
And there you have it. From basic structure all the way to advanced event processing, that completes our grand tour of the IRL keywords. You officially have the full vocabulary now. So the only question left is, what complex problem are you going to solve first? Thanks for watching.